Hi everyone, I hope you're okay. So I know we're getting to the end of the year and everybody's tired of this, and I am too. We have just a couple more assignments to do and then we'll be finished and we can enjoy our summer. So let's get to it. We have integration by substitution, part 3. So this is going to be very similar to what we did in the last couple of lessons, but these will all be trig integrals that we're going to look at. So I gave you the table of trig integrals a while back, but I didn't want you to have to go looking for it, so I just pasted it again into this assignment so you would have the rules right there and make this as easy as possible. I know everybody just wants to be done. I get it. Okay, so let's get to it then. So number 1, we have the integral of cosine, and in parentheses 6x dx. Okay, so we are still looking at u substitution, and you're going to look for whatever's inside the parentheses. So in this case, it would be 6x, and say that that is your u. Yeah. Okay, then you're going to take the derivative of that. So you would say it's du equals. So when you take the derivative of 6x, that would just be 6 and then dx. Now remember, the goal is to have something to fill in back here, substitute in. So in this case, we would divide both sides by 6 then. That will cancel the 6's, so you'll have du divided by 6 is dx. Okay, so you're going to come back over here and fill in what we just found. So you'll still have your integral for now. Instead of the cosine of 6x, you'll say it's cosine of u, because that's what we made u equal to. And in place of dx, you're going to put in du divided by 6. Okay, now usually when you do these problems, something cancels at this point, but not always. Like in this case, there's nothing here that cancels. So think of this as being a 1 cosine u, and then that being a 6, like 1 over 6. That would be like the fraction, 1/6. So I am going to take out 1/6 and put it before the integral sign, like multiplied to it. And after I take that out, I would still have cosine of u du. Okay, so now you would look at your table of indefinite integrals, and you'll see that the integral for cosine x is sine x. So you would keep the 1/6. In place of this, you would put sine of u in this case. And then, of course, you need your plus c. And then for your last step, you just go back and fill in whatever u was, which was 6x. So your answer for question number 1 would be 1/6 sine of 6x plus c. Oops, not 6, plus c. And there we go. That would be your answer for number 1. All right, and that'll do it. Okay, so for number 2, we have an integral, and it is sine to the 7th x, and then also cosine of x dx. Okay, so for u, what I want to do is pick the more complicated one, which would be sine of x, since it has the 7th power, and say that u is sine of x. Do not use the 7th power. We'll deal with that later on. We'll just look at u being sine of x for now. Okay, so now we're going to take the derivative of this. So it would be du equals. Now these are derivative rules that we've been studying throughout the year. But if you look at your table, just think of it in reverse. Like look at the right side and find sine of x, and you'll see that it's cosine of x. So it would be cosine of x dx. And I want to have something to fill in over here for dx, so I'm going to divide each side by cosine of x. That way that cancels, so you'll have du over cosine x equals dx. Okay, so now we're going to do the substitution part. So you would still have the integral. Instead of sine to the 7th x, remember that u is the sine of x. So that would turn into u to the 7th. Now you would not change the cosine of x, that would still be there. And then remember dx, we now know is du divided by cosine x. So in this case, the cosines would cancel. And we're left with the integral of u to the 7th du. Now when you take the integral of u to the 7th, remember this is like a polynomial with an exponent. So remember you write it as a fraction, so it would be 1 over. And it's this number plus 1, so that would be 8. And then the exponent is the same thing. Add 1 and it would be 8. And then plus c. And in your final step, you'll just go back and fill in what u was. So u was the sine of x. So your answer would be 1/8 sine of x. Now, since it's to the 8th power, remember it's typical to write the 8 first, and then sine of x like that, and then plus c. So here would be your answer for number 2. So notice we're doing the exact same process as we did with all the other problems with u substitution. It's just these are trig ones, and you'll just follow the rules. And the nice thing about it is you didn't have to memorize these. You would have had you taken AP. So you just look at a table, that's great. Okay, so number 3, we've got the integral of secant 5x, tangent 5x, dx. Okay, so we're going to start by saying that u is the part that's inside of the parentheses in each case, which is 5x. So I'll say u is 5x. Then I will take the derivative, so it will be du equals, now the derivative of 5x is just 5 dx. And we're going to substitute for dx, so I'm going to divide each side by 5. So those 5s will cancel out. So it'll be du divided by 5 is dx. Okay, so now we'll go back and substitute. So we still have the integral sign, but instead of the 5x, we're going to use u in both cases. So it'll be secant u, tangent u, and instead of dx, I'll put du divided by 5. Okay, in this case, nothing cancels. So this is kind of like number 1, where you can think of that there's a 1 in front of the secant u. So you can think about it as 1/5 that you would take out. So in front of the integral sign, you would put 1/5, then the symbol, and then you still have, oops, I wrote that backwards. I was trying to say secant. So it's secant u, tangent u, du. Okay, so now it would be time to look at the table of indefinite integrals, so keep the 1/5. So if you find this on your table, you'll see this is the second one from the bottom, and this is equal to the secant. So you would say this is secant u, and then plus c, of course. And then your final step is to fill u back in, so that would be 1/5 secant of 5x plus c. So there's your answer for number 3. Okay, just a couple more. So we've got 1 plus tangent of x raised to the 8th power. Oh, there's a secant squared there too. Missed that almost. Okay, so secant squared dx. Okay, so I'm going to begin by saying that u is whatever's inside the parentheses here. So let me do that first. So u will be 1 plus tangent of x. we will take the derivative, so it will be du equals, 1 is a constant, so the derivative of 1 would be 0, so that would be gone. The derivative of tangent, remember you can think of your integration rules backwards, that would be secant squared. So it would be du equals secant squared x dx. So I want to have something to plug in over here for dx, so I'm going to divide both sides by secant squared. And those will cancel, so you'll have du over secant squared x equals dx. Okay, so coming back over here, I'm going to keep the integral sign on this step. Instead of the 1 plus tangent x, I'm going to use u, so that will be u to the 8th. But you don't do anything with the secant squared, leave that there. So it's secant squared x. But in place of dx, I'm going to put in this, du over secant squared. Okay, so notice that this time the secant squareds would cancel, they're exactly the same. So you're left with the integral of u to the 8th du. Now at this point, this is just like a polynomial, u to the 8th. So you would write it as a fraction. It would be 1 over, add 1 to this exponent. So instead of 8, it would be 9. And then you would also have the 9th power. Remember, these are supposed to be the same. And then plus c. And your last step is to fill in that u is 1 plus tangent of x. So it'd be 1/9 in parentheses 1 plus tangent of x raised to the 9th power plus c. Final answer for number 4. Remember, you can always pause if you need a sec to catch up. All right, so one more. So we've got the integral of sine square root of x over square root of x dx. So when I choose something for u, I'm going to use just the square root of x. We'll deal with the rest of it in a little bit. So just say u is the square root of x. Now keep in mind from previous lessons earlier this year that you can think of any radical as a rational exponent. So the square root is the same thing as x to the half power. The square root of x and x to the half, same thing. Okay, so now we can take the derivative, so it would be du equals. So remember the derivative rules is to multiply the exponent to the front, so that would be 1/2. And then subtract 1 from the exponent. So 1/2 minus 1 would be -1/2 dx. Okay, so we're going to simplify this up a bit. So if you have the half, just keep that the same. But a negative exponent means that you put the answer in the denominator, and since it was a half, it would be the square root of x. So the square root of x is x to the half. X to the negative a half would just put the square root on the bottom, and then dx. So keep in mind that I'm trying to plug in something back over here, so you always want to solve for dx. So in a case like this, since this is a fraction, I'm going to multiply both sides by 2 square root of x. So that way this one and this one will cancel out. So I'll have 2 square root of x du equals dx. So that was a little bit harder to get the derivative of, but now we're finished. Okay, so now we're going to go back and substitute. So we still have the integral sign. And instead of sine of this, I'm going to say it's sine of u. Now I don't want to change this to a u because I'm trying to cancel it with something over here. So just leave the bottom square root of x there and only fill in the u on the top. And then rather than dx, fill in this 2 square root of x du. Okay, so now this square root of x and this square root of x would cancel. And you have this 2 that you could put on the outside of the integral. So now you have 2 times the integral of sine u du. So much simpler once we get to this point. Okay, so we'll keep the 2 on the outside. Look at your chart. So the integral for sine of x is the first one. It's negative cosine of x. And then plus c. Okay, before I do anything else, this negative sign would be best to put over here with the 2. So I'm going to change that to negative 2 cosine, u plus c. So notice all I did is I took that negative sign from the rule and put it out here with the 2. Okay, then the last step would be to fill in that u is equal to the square root of x. So it would be negative 2 cosine square root of x plus c. And we have it. Okay, so that's it for today. Hope y'all are doing well and keep working just a little bit longer. I know it's hard. It's hard for me too. Just keep on keeping on for a little bit longer and we'll be on summer break before we know it. Bye y'all. Love you. Bye-bye.